Hey, thanks for taking this tutorial uh, about event-driven programming using Spring Cloud Stream. I appreciate. Hi, I'm Ishwaran, one of the developers from EDM team. I have Prashant with me, one of my team member. In this tutorial, we will cover EDM architecture at very high level and some of the challenges that we faced while implementing it, and what is Spring Cloud Stream, why we chose Spring Cloud Stream for event-driven implementation, and how Spring Cloud Stream and Project React reconcile to solve some of the unique problem. And we'll have a demo of Spring Cloud Stream application. This is high-level architecture of EDM system. EDM system is completely distributed, highly scalable, um, containerized, microservices that are deployed in Kubernetes cluster. All these microservices are developed using Spring Boot. All these microservices have their corresponding queues. We work with multiple messaging system. For our local development, we use Kafka, and for all higher environment, we use Azure Service Bus. Uh, all the microservices are sessionless and scalable, independent to each other. All these microservices can be scaled based on any external metrics, like metrics from Prometheus or or from QDepth. Um, this is this is basically EDM edge service, which has both gRPC front as well as event-driven. Event-driven. So these um, all the upstream system will be posting a request either through gRPC API or to the queue to which this edge service listen to. Upon receiving the request, edge service will create an workflow. It will create workflow dynamically based on the request type, and once it's after creating the workflow, edge service will persist um, the workflow in Snowflake database. Um, as I said, the workflow will be created dynamically. By that, what I mean is on the fly, depending upon the request type, edge service will determine what are all the process that will be part of the workflow. So certain request type can have all the process participating in the workflow, and certain requests may have very few process participating in the workflow. Once it is persisted, edge service will generate an event um, for orchestrator, and it will post a request for orchestrator to consume. Orchestrator microservice will consume the request, and and with the request, it will be able to correlate to the workflow which is persisted in Snowflake database. It will retrieve the workflow, and it will derive all the process that are involved in the workflow. It will generate an event and post a request to the first process in the workflow. So the first process in the workflow will consume the request from its respective queue, and it will start the process. Once the processing is done, um, the service will send a success response back to the orchestrator. Orchestrator will receive the success response, and again it will correlate success response to the workflow, and it will identify the successor, the next process in the workflow, and it will generate the event and post the request to the corresponding queue. The same process continues till all the process in the workflows are done with this task. Once all the process are done, um, orchestrator will update the status of the workflow, mark it as success. This is real high level of what EDM does. While implementing this, we encountered some of the challenges. and we will discuss what are the challenges that we encountered and how we overcome those challenges. One of the major problems that we had was we wanted a system, we wanted all the microservices to be agnostic of underlying messaging system, service underlying messaging system. As our local environment, we will be using Kafka as a messaging system. And in all higher environment, we were using Azure Service Bus as a messaging system. So we want very, very minimal code change or no code change for all these services um, to connect to any of the underlying messaging system. Uh, this is one of the challenge. And the other problem we faced was the orchestrator is completely dynamic by nature. Um, it's completely dynamic in a way that it cannot be binded to the stat to any of the queues statically. Based on the request type, orchestrator should be smart enough to route the request to appropriate queue. These are some of the challenges that we faced while implementing this event-driven system. Now, Prashant will explain what is Spring Cloud Stream and why we chose Spring Cloud Stream to address some of these challenges. Prashant, can you please share your screen?
Yeah, sure. Yeah, I'll be sharing the screen. Okay, so Ishwar already explained at higher level what is the architecture and what were the major requirements for our going behind this Spring Cloud Stream framework. So before going to how it addresses the challenge, let me tell you at higher level. It is a framework from the Spring Cloud family, which allows you to create a event-driven microservices in a scalable fashion. And then you can this microservice can talk to each other or a broker. So one of the important challenge was able to switch over the broker. Like if you want to have Kafka or you want to go to Azure Service Bus or a RabbitMQ, you should be able to do with minimal changes to your application. So this Spring Cloud Stream does all the hard work actually behind the scene, to connecting to this brokers in a very simple manner. Like you just have to do few configurations and you are able to switch your to the different broker without you don't have to do any single line of code change for that. Just a few lines of configuration changes. And Ishwar, when he goes over the demo, we can see how easy to switch over between Kafka and messaging service bus. So that was the major reason to choose Spring Cloud Stream. Um, Apart from this, it comes with many different features. Like the first one is it allows you to develop your application in a active or imperative style, or you can even mix and match both the styles. Then second, there is let me make this presentation more. So you can write this plain POJO methods, right? The plain functions, and you can easily bind this function directly to the channels or to the communication channel, basically. So you see, this is a producing, which is a bind producer, which it does is it creates events, and these are the consumers. So you can directly bind these functions. There is the message which flows between your function, basically your application and binder. They can be converted to and from that events to your POJO object transparently, and Spring Cloud Stream take all the work behind the scene. Then you can compose these functions, basically these consumer functions, and create higher functions. So it gives the functional feeling to your application, and it has a nice capability to handle incoming and outgoing data as a stream of data. Uh, as I said, you can do a reactive kind of programming over here. Additional benefit. Let me go over the key concepts. Uh, these are important when we go over the demo. We are going to see how they are actually configured or implemented in the code. First is the channel. So channel is nothing but it represents a communication pipe between your application and your binder. So if you see there is a output channel and an input channel over here. The second concept is the bindings. So what are the bindings? So as I said earlier, you have these functions which you can bind to your broker. So these functions you can bind to this either output channel, or if it's a consumer function where you consume the one, you can bind to your input channel. So as Ishwar already mentioned, we need an application. We need to dynamically bind many channels basically, and you can easily achieve this using the Spring Cloud Stream. You can have multiple bindings. Binder is a nice abstraction over your messaging framework, messaging broker. So it can the broker under the implementation could be Kafka, RabbitMQ, but all you configure is the binder. From your application perspective, you just need to know binder. The implementation can be anything, any vendor specific like Kafka, RabbitMQ, Azure Service Bus, or any else, anything more. Then the fourth thing is the stream listener. It is nothing but some function on your application which it listens to the input events coming from your message broker. This I think I already kind of covered. It's a message converter is nothing but the serialization and deserialization of your application event. The events, and between the events and your POJO objects. So this all about the Spring Cloud thing. So in a nutshell, it just makes your application easy to connect to the broker in a broker agnostic basically. Second, let me go to the second framework which we are using. It's Project React.
Hey Prashant.
Yeah.
Question.
Yeah.
Quick question. Any specific reason why we are blending Project React with Spring Cloud Stream?
It's a good question. So Project React and Spring Cloud they blend together and allows you to create an application which you can treat the events coming as a stream of events and asynchronously. It's nothing but an implementation of reactive stream specification. So it comes with all the benefits of the reactive stream, like you can have retry mechanism, you can have error handling mechanism, then you can have a rich set of operators like a map, flat map, or filter, just like in stream. But you can handle them in an asynchronous and a non-blocking way. You can do nice composition of your functions. So all the benefits of the reactive can come hand in hand with your Cloud Stream. Spring Cloud Stream. So we in the current this tutorial, we are not going to go in depth. We are just barely scratching the surface. I'm just going to go over key concepts which we'll be using in the demo. So first is this publisher. Publisher is nothing but who can create the event. And second object is the consumer, which can listen to the events. So publisher, when it publishes the event, it calls this onNext method on the subscriber. And when it finishes publishing all the events, it calls onComplete, signaling that hey, I'm completed sending all the events. Then there's another concept called back pressure, where if publishers sending the events at a faster rate than a subscriber can consume, there's a way to give a feedback to publisher sending, okay, I can't handle anymore. Hold on for the further sending the further event. So that kind of mechanism is built in this reactive stream. So that's about publisher and subscriber. Now this publisher can be of two types. One is called mono, where you can publish 0 or 1 events, and the other is called flux, where you can publish finite or infinite stream of events. It's just specific for sending many events in a stretch. The last component which I want to cover is sync. So, and any application, a multi-threaded application, if you have just one publisher and your many thread accessing this publisher to publish their event, then you need to do in a thread set way. This sync creates a wrapper on this mono and flux, so you can handle this multi-thread situation in a thread set way. So this is one which we are using. I think all these things we are going to touch in the demo section. So I think I've covered these two frameworks. I think I'll now give control over to Ishwar so he can proceed with the demo.
Thank you, Prashant.
Yeah, forum is yours.
Thanks, Prashant. Now, in this demo, we have two microservices, one producer and consumer. Producer will produce an event, and the event will be pushed to a queue in Azure Service Bus, and the consumer will be consuming it. Now, with no code change, just changing the configuration, producer will produce an event, but the event will be posted to Kafka, and consumer will be consuming it. These are the two separate independent microservices. We'll see them in a demo. So this is producer microservice I've already created. It just has mostly empty classes. So Spring Cloud Stream is predominantly driven through configuration, like more of a configuration and very few code. So the most important thing or the starting point of the configuration is defining a function. First, we define a function. Now, what Spring Cloud Stream does is it will do component scanning and look for a bean definition with this name. So in this first demo, we are looking at imperative way of pushing a message to the queue. So we have already defined a function. As I mentioned, Spring Cloud Stream will do component scanning and will be looking for a bean with this name. So now we are going to define a bean. We have defined a bean with same name, and this is of type supplier. And there is a linked list already initialized with 3 elements in it. What supplier will do, each time it will check if linked list is empty or not. If the linked list is not empty, it will take an element out of it and pushes an element to the queue. That's all supplier will do. Now let's see how Spring Cloud Stream binds to the destination queue. So these are the other configurations that are required to bind against Azure Service Bus. So before that, we will require to add the dependency. Now we have added both the binders, Kafka binder as well as Spring Cloud Stream binder in dependency. Spring is basically smart enough to scan and find out the dependency, and depending upon the dependency, it will use appropriate binder at runtime. But in this case, as we are adding both the dependency, Kafka as well as Spring Cloud Stream, we need to define the default binder. By defining default binder, we are communicating to Spring Cloud Stream which binder to use at runtime. So we are instructing Spring Cloud Stream to use Service Bus not the Kafka. And then this is the connection string. And this is the destination. Destination is basically a queue name or a topic name. So EDM on-demand request will be the queue name. And queue entity type, we can define. Entity type can be either topic or queue.
Sure. One question. Could you explain me? Could you explain us like what is this on-demand producer hyphen out dot zero? So can you elaborate on more on that?
Perfect. That's a good question. So as I mentioned, the function definition, which is used for component scanning, and then we'll do the definition within our application, and then the same function will be binded to the corresponding queue. So we use same name here after the bindings. So this is basically this method, and then out is basically going out from the microservice. So basically it's a supplier. So it will always push an event to the queue or topic. So for supplier, it will be out. For consumer, it will be in. And then the number 0 is basically for representing partition. For example, if there are more than one instance of the service up and running, each instance can be pointed to its own corresponding partition. So in this case, since we are running only one instance, we are configuring it with index 0. Destination is basically the queue name, and then the entity type, as I mentioned, either queue or topic. Let me quickly show Azure Service Bus. So this is basically Azure Service Bus, and this is exact same queue against which we are doing this configuration. That's pretty much it. We did all the configuration to bind, and then the code is completely agnostic of underlying binder. So the code do not know to what binder it's going to push the event to. It's all taken care by Spring Cloud Stream. One another thing is Spring Cloud Stream will invoke supplier periodically with configured frequency. If there is no configuration provided, then it will invoke supplier every 1 second. So every 1 second it will be invoking supplier, and this method gets executed. I just configured it. I've modified and I've given value as 20,000 milliseconds. So basically 20 seconds. So every 20 seconds, Spring Cloud Stream will be invoking supplier, and the event gets pushed into the respective queue. That's pretty much about the imperative implementation. Let me start the application. Before starting the application, if you guys see, there is no message as of now. The queue is empty. The queue is still empty. So already a message is inserted. See, one message is already put into the queue. The two messages. The test message 1 is the message 1. That's this. So all the 3 messages are inserted into the queue. If you look at the time difference, 26:36, 26:46, it's basically with the interval of 20 seconds, each message got inserted into the queue. So that's because we have configured to invoke supplier method at the interval of 20 seconds. Now all the 3 messages are inserted into the queue. That's imperative way of pushing a message into the topic or queue. Let me clean the queue. Now there is no message in a queue. So now we saw imperative way of pushing a message into the queue. Now let's see how to use Flux with Spring Cloud Stream. So technically we are blending Project React with Spring Cloud Stream. So Spring Cloud Stream, by looking at the type definition of the supplier, it will check if it is of type Flux. It understands that Flux itself is a stream of messages. So it delegates periodic invocation of supplier to Flux. So it will just invoke once. It will not periodically invoke supplier, irrespective of whether we are having a configuration defined in application properties or not. It basically delegates the work to Flux. Let's see how it works now. I stop the application and clean the queue. Queue is clean. I'm starting the application. Queue is still empty. See, all the three messages got inserted in one shot. So exact 16:19 GMT, all three messages got inserted. And as I mentioned, that will be invoked only once. So no more messages gets inserted into the queue. Just these three. So, now there is a way in which we can even after defining a supplier of type Flux, we can still instruct Spring to invoke supplier method periodically. So instead of taking that responsibility of pushing a message on a periodic interval, even with the definition of Flux, we can still delegate the work to Spring Cloud Stream. For that, all that we need to do is define this as pollable bean. I'm going to stop the application. Like before stopping the application, let's check queue one more time. All that we could see is just three messages, not more than that. But by defining this bean as pollable, this method gets invoked every 20 seconds. On each invocation, all these three messages gets inserted. Let's check what pollable bean will do. So there are three messages already in a queue. I have not cleaned the queue yet. So it became 6 now at 18:09. Three messages got inserted. The other three also got inserted. See. Now these three at 18:09 and this is at 18:28. So technically the interval of 20 seconds. And every 20 seconds, it will keep inserting three messages to this topic, to this queue, sorry. Now another three got inserted. So this will keep inserting, another three got inserted. So that's even after defining supplier of type Flux, if we want the method to be invoked with configured interval, we can define the bean as pollable bean. Let me clean the topic. there is another object that Prashant explained in his slide. It's called sync. Sync is a wrapper on top of mono or flux. Let's see the behavior of sync. Now this is just a RESTful application. API is exposed. This API will receive a string as request param, and it will invoke a method in producer service. In this method, so no changes in the configuration. We are still connected to same topic. But in this case, it's no longer a pollable bean. We have defined it as a bean, meaning we are communicating to a Spring Cloud Stream, and we are requesting it to delegate pushing an event to the queue on us, so that it will not invoke supplier with the configured periodic interval by defining it as a flux and having it as bean. And we are defining a bean of type sync. So basically sync, as Prashant mentioned, it's a wrapper about mono or flux. In this case, we are using flux as we are defining it as many. If we want, we can make it as mono. And unicast, it's basically will not be broadcasted to multiple subscribers. Only one subscriber can subscribe to this event. And on back pressure buffer, I think Prashant already described about it. It's basically a communication between consumer to the producer. Consumer can send a signal to producer if it is throttling. If it could not able to take any more requests, it can send a signal to producer to slow down the number of production of the event. And the same sync is injected inside on-demand event producer. And all that this method will do is it will return a flux.
Ishwar, if you don't mind, can you go to the producer service? And,
sure.
How we're emitting here? Yeah. Can that line 21 there.
Sure. So the controller will be calling this method and will pass the argument that it received from a request param. So sync.emit. So whenever emit next is invoked, it will push this message into the queue. As I mentioned earlier, the complete delegation of pushing an event to the queue, Spring Cloud Stream delegated that work to flux. By seeing the definition flux, it delegated that work to flux. And here, by calling next, emit next, the message sync is driving all the pushing messages into queue on its own. Now let's start the application and check how it behaves. Application is starting. Application started. There is no message in the topic. I'm going to invoke the method. The message successfully put into the queue. Let's check. See, the message is inserted into the queue. So basically, we need not to wait for that configured interval of time. This is completely ad hoc. Whenever emit method is invoked, the message gets inserted into the queue. So this is basically demo 1 that we sent here. Let's call it with test 1. So that's the second message. That's the third message. So this is completely ad hoc. Whenever emit is invoked, the message gets pushed to the queue. So far we saw producer microservice. Let's start.
Ishwar, before you go to other, can you show the screen again? That controller.
Controller. Perfect.
Yeah. So what you say is essentially, if there are multiple threads, there's a multiple requests to this method at a given point of time, right? So there will be multiple threads, right? Which will be associated with this method call. So that sync will should take care of synchronizing those call to emit.next. Am I right?
Perfect. Yes, that's really good question, Prashant. You are right. Sync is thread safe. I think one of the slide you covered, it's completely thread safe. So even if the method is invoked by multiple thread, it will coordinate between the thread. That's basically thread safe.
Okay, that's good.
Perfect. Now that we know there are 3 messages in the queue, let's consume these 3 messages from our consumer microservice. Consumer microservice, again, I've created the project, but there is no application. Application properties is completely empty. Exactly similar to our producer configuration, we are defining a function so that Spring Cloud Stream can do component scanning. And we have a consumer, a being defined of type consumer with same name. All that this method will do is whatever string it consumes, it just do system.out.println with inside the consumer with that whatever it has received, whatever string it has consumed. We have used same name as this, and we need to do all other bindings.
Ishwar, one more. I have one more question there. Can you go
Sure.
back to the function which you have defined? In the function in the class, consumer application class.
Right.
So here on line 16, right? So if you want to change this consumer of a particular type, right? Here it's a string. So if you want to have another object, like complex object, right? So how does you think like some your own project, like an employee or something?
Perfect.
So how is it converted? Like how does do you know how does it converts into event message based upon the
Perfect.
house?
So as while you covering one of the slide, I think you mentioned Spring Cloud Stream comes with the default message converter, JSON to POJO, POJO to JSON. So the marshalling and unmarshalling back to JSON, JSON to POJO is taken care under the hood, out of box. Now, if you want, we can change the MIME type. MIME type can be anything like XML or gRPC. We can change the MIME type. We can either use built-in converter or we can provide our own custom message converter. Spring Cloud Stream will be able to use them to do this message conversion.
All we have to concentrate in just defining the function, what message you want to, or what kind of message you want to consume. That's it.
Perfect. Let's add other configuration. Here it's pretty much similar. Gradle build, we already included Kafka binder and Azure Service Bus binder. Since there are 2 binders configured in the dependency, Spring Cloud Stream will not know what binder to use at runtime. So we are defining default binder as Service Bus. and then this is the connection string. And this is similar to our producer configuration using same method name. In is basically into the service. Since it is a consumer, this has to be defined as in, but the producer, we define that as an out. 0 is basically the instance index. If, as I mentioned, if there are multiple partition, each consumer group pointing to their own corresponding partition can be defined. We can give the corresponding index number there. Destination, it's basically pointed to the same queue, and entity type is queue. So as we can see, there are 3 messages. Let's start consumer application.
Essentially, Ishwar, what you're saying is just that in and out configuration tells consumer string. It's a consumer or a producer. Basically.
Right.
So that's a very minimal change, which is.
Yes. As like correct. So all the 3 messages are already consumed. Demo 1, test 1, test 2. Now if we look at, so all the 3 messages already consumed. Now the queue is empty. Now let's post another message, test 3. Message already successfully inserted. We will not see that here because it would have already got consumed. Test 3 already consumed. So that's consumer part of it. Now the fun part, changing the binder. Without changing the code, let's change the binder. Instead of Azure Service Bus, let's configure it with Kafka. And stopping the service. So I already have Kafka up and running in my local. So since we have both the binder defined in dependency Gradle build, we are adding default binder as Kafka, and then the broker's connection string. And this, none of these configuration changes. Everything else remains the same. Let me start the application. And on consumer side, again, I take away the service bus binding, add Kafka binding. Let me start the application. So without touching any line of the code, just changing the configuration. Now we successfully both microservices binded to Kafka. Let me post a message. So message successfully into the queue. Let's see consumer test 4. So the consumer consumed test 4 message. Let's try one more. Test 5. Test 5 also consumed, but this time not through Azure Service Bus, but through Kafka.
Just changes binder definition.
Correct.
Yeah, that's good.
By just changing the binder, we could able to successfully switch between the binders. And as I mentioned, Spring Cloud Stream is smart enough. By looking at this, it will know which binder from this dependency needs to be used. If we don't have to two dependencies. If we just added one, we don't even need to specify default binder. Spring Cloud Stream is intelligent enough to identify and map the available binder against this configuration.
So one more question, like I see you have configured one queue here. Can we configure multiple queues in same application with a different?
Perfect. Yes. All that we need, if we are configuring multiple queue, all that we need to do is add one more function definition. Consumer response 1.
It could be anything there. Yeah.
Yeah, and then have all these bindings defined for consumer builder response 1.
We just repeat those lines, line 4 and 5 for
line 4 and 5.
Every different queue and every different function. No.
Perfect. Yes, configure to their respective queue and have their definition defined inside the application. Define what that binding method needs to do. That's about it. And not just that, if you want, we can bind to, it can be binded to, we can even configure multiple binding by defining our own binder. So each binder can be configured to, let's say one binder can be configured to topic, the other binder can be configured to queue.
You can have multiple, basically one can be a pub sub or one can be just a queue type kind of configuration. Okay. So essentially, you can have multiple consumer and producers configured in your same Spring Boot application if it need be.
If need be, correct. Some of our service in EDM system already implemented like that. I think that's all we had for this tutorial. If you guys have any question, please feel free to reach out to either me or Prashant. Thank you so much.
Thanks, Vishnu, for the demo. Thanks. Thanks all.
Thanks, Prashant.